wait for everyone to come in first. I guess we have still a few other participants waiting to come in. So, okay, great. I think we should get going soon. Okay, good afternoon, everyone. Thank you for taking time on a Sunday afternoon. Again, just to be sure, I just want to make sure that you can hear me. Mabel, you can hear me, right?
Yes, I can.
Okay, I assume that everything is okay. Great. Thank you for taking time this afternoon to join in this session. I think today we are trying to do a few things. Um, Let me introduce myself. I am Dr. David Chew, the Deputy Head for the undergraduate programs at the Department of Statistics and Data Science. Today we want to talk about the statistics degree major at the College of Humanities and Sciences. So that's what the agenda is. So I think there are a few things that I want to offer some advice. So I think for today and even for the coming Saturday, I think the important thing for you to decide first is which university should you come. I mean, if you are thinking about a local education in Singapore. And obviously, I would want to persuade you to come to NUS. All right. And why do you want to come to NUS? I think it is quite important for us to know nowadays that with the advent of large language models like Gemini, Anthropic, and Deep and all the other OpenAI related tools, it is quite important for us to not just make use of all these tools blindly, but it is important for us to learn how to learn. Ultimately, these tools are very good. I think they are very good, and I use them a lot in my work, professional work and in classes. But I think it is important for us to understand how all these things work, and more importantly, you need to know how to evaluate whatever these tools give you at the end of the day. Because the thing is, at its current state, all right, all these large language models, they are good. However, I think ultimately a human being needs to make a final assessment whether whatever is coming out from all these models, they make sense or not, all right? Because of the fact that the materials that are used to train all these models, they might not be finely tuned. So it is important for us to still provide some domain expertise in trying to understand the outcomes that comes from all these tools. All right. Um, so I think it is important to come to the university to learn how to learn so that you are able to make use of all these tools, in a appropriate way, even as Singapore is moving towards an AI nation and so on. And so, firstly, then come to NUS to study because I really think that it's a good university. And then the second thing that I'm trying to convince you today is, come to the College of Humanities and Sciences and study statistics. All right. So what is so attractive about statistics? It's really about how you can learn from data. It is the science and art of learning from data. The thing is that we are surrounded by data everywhere, different types of data nowadays, actually. It's not just about numbers, it's about text, it's also about images and so on. All right. So statistics primarily is about learning from data. And where do we find data nowadays? It happens in many different domains. You can see a lot of data from the banking, financial, and accounting sectors. You find data in healthcare as well. In fact, I have some interaction with some colleagues from Ministry of Health, and then we have colleagues working in the School of Public Health. They all make use of statistical methods to do modeling, to do projection, to do policy making use of good practices in statistics. And also in consultancy, you need to make important business research and business decisions. And statistics is very useful in making good and convincing arguments and how you should do business. There's also in the government sector, in MOH, MPI, MOE, GovTech, the Minister's office. You need to analyze data so that the different agencies they can make good decisions based on data, so that the advance of the nation can be can move forward. All right. So data it's everywhere in many different domains. I just want to play a quick video. This is a video that is produced by the faculty. In fact, if you go to this link later, you can see and find many different videos for each of the different majors in the College of Humanities and Sciences, including classes from or rather majors from the arts faculty, arts and social science, and also the science faculty. So let's just listen to this for a while. Oops, it's not working very well. Major. Yep.
Statistics, the science of how data is collected, analyzed, and interpreted.
You will be able to spot trends in numbers, make sense of weather patterns, predict election results, understand how a virus spreads.
Or you could be assessing billion-dollar deals.
The point is, a stats major has lots of career options.
My course allows me to explore different fields like quantum computing. This could take statistical tools like machine learning to the next level. This is where the future of quantum computing is being shaped.
A statistics major will do courses ranging from theoretical to applied, and you decide
where you want to specialize in data science or finance and business statistics.
Question.
Why is there a pig and chickenpox in Asia in February? We study historical data for the insights. This will enable healthcare professionals.
Okay, I understand that the video might appear a little bit choppy because we're trying to do a lot of things and the bandwidth is probably limited. But I really encourage you to go to the this particular link. So you just go to YouTube and look for the NUS College of Humanities and Sciences. And over there, you will find various different videos for each one of the different programs and the majors in the College of Humanities and Sciences. I think I also want to say from a personal, as a personal advice that if you are able to, do come to the physical open house that is happening next Saturday in NUS. I think for a lot of you who are trying to make decisions, it is good to actually go down and listen and talk to as many different professors and also students in the open house so that you can find out a little bit more about the various majors and degree programs that NUS has got to offer. I personally had a chance to talk to some of the children of some of my friends, and quite a number of them they were saying that, oh, I don't really know what I want to do, and and so on and so forth. So it is quite difficult for someone at your age. I'm assuming that most of you are in your late uh, teens and early 20s or something like that to decide what you want to do. So I think it's useful to go down to talk to people. Sometimes you might never know. Perhaps you might be thinking about a certain subject like economics or geography or statistics or mathematics or history, and you might have maybe not a very full picture of what each one of the discipline does. So it's useful to go down and talk to someone, and you might discover that hey, maybe economics is not just about writing essays, and history is not just about memorizing facts and so on. So I think it's useful to go down and talk to different people. And very often in the universities in Singapore, there are constantly new programs coming out. So you might also want to go down and talk to colleagues in all these different disciplines. Right, so I hope to see many of you coming down for the open house that is happening next Saturday. If you pop by the statistics booth, there you can perhaps have a chat with myself and or some of my colleagues over there. All right. So I think we have a very brief idea of what statistics is about, and I think for many of you and perhaps your parents or even parents among our mates, the great concern is what kind of jobs do a person with a major in statistics do. So you see this word cloud over here. These are basically the different companies and the institutions and organizations that our graduates have gone to work in over the years. So it's not one particular year, but it's aggregated over different years. What you see over various different organizations, you have GovTech, Ministry of Education, maybe teachers, and then banks over here, and banks and financial institutions, Singapore Airline, Bike Dance, Grab, Unilever, Tan Tock Seng Hospital, and so on and so forth. The point that I'm trying to make over here is that the major of statistics, the graduates from this program, they go to many different industries. So it is not restricted to one particular type of industry. And the commonality that you see in all these institutions and companies and organizations is that the work that our graduates have gone on to do, they are all doing work that has got to do with data, mostly. Of course, there are some of them who will work in some other areas, but most of the graduates from our department, they work in industries that require them to exercise skills in data analysis, data collection, and decision making that requires a data, information. So that's basically the point that I'm trying to make. That there are a variety of different industries that a degree in statistics can bring you into. These are just to highlight, these are two graduates of our department who has gone on to work. So one of them, he graduated in 2021. He's now an AI engineer. All right. And then we have another alumni. She graduated in 2018, and now she works for a hedge fund company called Point 72. And I think they are doing great jobs in the industry. So this hopefully can assure you that there are good jobs waiting for people with statistical training. All right, so now I want to talk a little bit about what statistics is really about. Very different from what most of you would have encountered and maybe experienced at maybe high school or JC and so on. Statistics is more than just reading graphs and making summary statistics and all those. But statistician, they actually engage in a variety of different activities. All right, so it has got to do with how you want to design and how you want to analyze complex surveys, experiments, for example, drug trial and research studies that on health, consumer, and business issues. All right. And the main thing is that we want to be able to make informed decisions under uncertainty in basically every single field that you can think about, whether it's in business, economics, engineering, and also in science. So that's what statisticians do. And let me just say a little bit about the different industries and different domains that statisticians work in. So they work in industries as diverse as, for example, banking and finance. Quite a lot of people are working in, for example, trading, high frequency trading, and so on. You need to be able to employ statistical methods to evaluate certain investment strategies. Like for example, when you buy a insurance policy, there are actually people who actually have done the sums and the math and the statistics to make sure that the portfolio, the industry, the insurance policy would be able to support the customers who buy the policy. It is basically what we call risk sharing. All right, not everyone will eventually for example, cash on a insurance policy. But overall, because everyone pull in their money in a particular policy, some people in need, when they need to, they can actually benefit from such policies. So that's one area where statisticians are working. And in consumer research, statisticians can design and evaluate products. They for example form what is known as focus groups, and maybe even small groups of customers who will try new products. I know of a very big consumer product company. They very often they would need to, for example, gather testers who will test new cosmetic products. So what they do is they will send different products to focus groups of testers, and then they will need to design experiments and design how they want to collect data so that they can show and they can demonstrate that this particular, for example, facial product is good, and it actually brings a good outcome for user for such products. So in consumer research, statistics can be used, and even something as simple as how you actually place a product. It has an effect on how the sales of a particular product it will do well or not well in a supermarket. I think you would have noticed that when you go into a supermarket, certain types of products are placed at the storefront, and then certain products are placed further into the premises of the supermarket, and this has some statistical basis on it, so when you place certain products at a certain place, customers are more likely to buy certain products. So these are things that statistics are involved in too, actually. And I mentioned before, government also routinely collect data. So this is the previous census. So a census is basically a major survey that the government collects on a 10-year basis. So the one that happened most recently was 2020. So these are important data that the government collects. So if you're interested, you can go and take a look at the census product. There are lots of very interesting stuff. Things like in every new town, what is the amount and the percentage of residents who take a certain type of public transport to work, and how long do they take, and so on. So you see that all these are very useful for the government to plan policies and to maybe push out new bus services that you can read about in the news recently. All right. So these are very important data that can be used to inform how government and company apply policy. And definitely in medicine and in public health, statisticians play a rather important role as well. If you remember, quite a number of years ago, we were in the COVID situation. Some of our colleagues who are basically trained statisticians, they actually do quite a bit of modeling to decide, at certain periods of COVID, what would be a safe, size of group size for people to gather. So if you remember, and I think you should be young enough, old enough to remember that there were certain periods where the government says, okay, 5% at the very most together in a place, and then it changed to 7, and then to 9, and so on. So all these figures, they didn't come out from the thin air, but I believe they have consulted statisticians. In fact, I know of a colleague who's involved in all this stuff. So what they do is they will set some parameters and model. Okay, so if we have a group of X number of persons, how would the spread of the virus be like? So these are actually known statistical skills and procedures that people have been doing for quite a number of years. So these are very useful in public health and in medicine as well. So I hope I have managed to showcase a little bit of how statistics is useful in various different industries and sectors. And so now the question is, so you might say that, okay, I'm interested in statistics, where should I study statistics? So I would recommend that you come to NUS, because we are the only university in Singapore to offer a degree in statistics, all right, through our department. The department is known as the Department of Statistics and Data Science, and then we are under the College of Humanities and Sciences. So if you're interested to do a degree or a major in statistics, what you need to do is you can't apply to the department directly, nor can you apply to the degree program directly. You need to apply to the College of Humanities and Sciences. All right. So I hope some of you might have had the chance to listen to the curriculum talk in the morning about the CHS. So that's the abbreviation for the College of Humanities and Sciences. So essentially, what needs to happen is you want to apply to the college. And then after you gain entry into the college, you declare a major. For example, you can declare a major in statistics or a major in data science, history, geography, English language, Chinese studies, physics, chemistry, and so on. All right. So that's how it will happen for you if you're interested to do statistics. So you apply to the college first. And after you gain entry to the college, you declare a major just before you begin as a student in the college. So maybe I'll just say a little bit about the department. We have about 40 or so full-time teaching faculty members. A lot of us are very dedicated teachers, so you can be assured that we do our very best to train up our students in the discipline. And we are rather highly regarded internationally. I will show you a slide later. And we have many accomplished scholars with diverse research interests. Now, these are some of the areas that faculty members are involved in terms of research. A lot of these terms might sound very foreign to you. That is fine, because the point of this slide is really to tell you that you are learning from the experts, all right? So if you want to do statistics, you want to learn from people who knows the discipline well. So this particular slide over here shows that the department is quite regarded in the world globally. If you look at the bottom left, sorry, the bottom right to you, we are ranked number 10 in statistics and operational research in the world. All right, so this is based on the QS survey that is last year. All right, I believe that this year's survey is not out yet, but I think the point that I'm trying to make is that we are a group of good researchers in the area of statistics. So you can be assured that you are learning from the experts. This next few slides I will go through very briefly because I think that some of you might have gone through the CHS briefing earlier in the morning. But very briefly, you recall that the statistics department is under the CHS, which is College of Humanities and Sciences. And under this college, everyone would need to take 13 courses for the degree, for part of the college requirement. And then for the major, for example, in our case, we are talking about the major in statistics. You need to read another 15 courses. All right, so that is roughly about 1/3 and 1/3. And the final 1/3, you are free to do whatever you want with it. So this is the final 1/3, which is what we call the unrestricted elective. Quite a number of students, what they do is they do a second major. For example, quite a number of the statistics and students in the department, they do a second major in computer science, for example, or you can choose a minor. There are many different and many interesting minors in the faculty. So there are students who do a minor, for example, in Korean studies, theater studies, or forensic science, and so on. So this is very briefly how the degree requirement is like. In total, you need to read a total of about 40 courses. So that's about 160 units. So the major requirement is 15 courses. The way that the curriculum is designed in this way for CHS is that we want students to be exposed to have a broad-based education. All right. So for example, for someone who wants to do a major in stats, he or she will spend about 30% of the units taking the major courses, and then 33% is fixed. Everyone has to do the 13 courses under the CHS curriculum. and then he has about 30% left of space to take whatever he wants. All right. If he's not thinking about a second major, then he can take courses from all over the place within the university actually. What is quite common after we run the CHS for a number of years is that we discover that quite a number of students, they actually take up a second major I think some students, they take out a second major in computer science or maybe economics or some other majors that go with it. Of course, for someone who is very dedicated to a certain major, you can actually use up the UE space on all the other courses within the major as well. So that will this will be how it looks like for someone who wants to take only stats courses and then finish the wanted curriculum, core curriculum courses. So you have quite a bit of freedom, and I won't say too much about this particular slide. You can check out some more details in the CHS website. I mean, the basic idea is that we want students to have a broad-based education, and the main thought is that nowadays a lot of issues that we need to deal with are no longer very focused. You need to be able to integrate, different insights from different diverse disciplines. So it is not something that a particular one discipline can solve nowadays. So for someone who works in statistics, you might need to have some understanding of biology, some understanding of geography, and some other disciplines, so that you are able to deal with the problem at hand meaningfully. All right. So that's what the CHS curriculum tries to do. You want to train someone that is broad-based, so that you can deal with the modern questions that are no longer uni discipline, but they are multidisciplinary. So these are the undergraduate programs in the department. So if you pick up the major in statistics, you're going to graduate with a primary major in statistics with a bachelor's honors degree. And for students who are interested to take up this major, the so-called course prerequisite is that ideally you should have a good pass in mathematics or equivalent. So this, I must say a few words about this particular prerequisite. The idea is that in order for you to progress well in the degree program, it is important that you have a good pass in mathematics. If not, you might find that you need to work a little bit harder. All right. But on the other hand, for those who don't have a math degree, a math pass at A level or equivalent, it is still possible to take up the major, except that you might need to read some kind of bridging classes so that you are up to speed in terms of the mathematical background. All right. So that's the major in stats, and the third bullet point over here says also that if you really like if you really like statistics, you can actually pick up an extra specialization. And we have two specializations for students in the stats major to choose from. One of it is in data science, and then the other one is in finance and business statistics. I will say a little bit more about the specialization in a few slides later. So very briefly, this is how the program structure in the statistics program looks like. You need to read 13 courses from the common curriculum. And then for the major, you need to read 60 units, which is 15 courses. And then you have another 12 courses that you can use freely. These are known as the unrestricted elective. But a minor technical detail. In fact, one of the CHS common curriculum course is what we call a data literacy course. And this is highlighted over here, data literacy. It happens that the first course in statistics, it can be used for this particular requirement. So actually, when you take the statistics major, all right, the first course in statistics can be counted towards the CHS curriculum. So the effect is that instead of taking 13 courses for the common curriculum, you just need to take 12, because the one course from the stats major counts towards the 13. All right. So what this means is that you just need to take 48 units, which is 12 courses for the CHS common curriculum for the stats major. And this also means that now you have one extra, one extra course that you can choose in the unrestricted elective courses actually. So that's a nice benefit for the stats major. I want to next say a little bit about how the curriculum is designed. I think all of you will discover very soon when you come to the university that the mode of learning and the mode of how we want to train students will be, I would say, will be quite different from what most of you have experienced at levels prior to the university. The fact is nowadays a lot of people can just use a large language model like ChatGPT, Gemini, Claude, or DeepSeek, and so on to answer a lot of questions. All right, but what might be missing is that you might or might not be able to evaluate the answers. All right, that these models gives you. In the older days, what I used to say is that anyone can pick up a statistical software and run a regression model or do a t-test and so on, but you might not understand what is happening, and the more important thing is you might not be applying the most appropriate method, all right, in analyzing that particular type of data. So that said, this brings me to my point, which is that the emphasis in the major, in fact, I believe for a lot of discipline is that it is not just about knowing how to do, but you need to know why we do certain things. All right. So the emphasis in the statistical curriculum is then on problem formulation and what we call statistical thinking. It's essentially why we want to do certain things certain way. All right. So rather than just applying the method or the models blindly without thinking much about whether it is a suitable method or a procedure to apply or not. So that is very important because the fact is a lot of things that we learn in the university, they will very quickly expire. In fact, some of the stuff that you learn in the university, they are probably things that has been around for many, many years. But they are still important for us to learn because they teach us how we can approach a problem. All right. So the advice that I give is, when you learn stuff in the university, don't just learn the method, but learn why the problem was formulated this way and why the problem was solved this way and why a certain procedure was applied to it, because these are the useful skills that you can use for life. All right. So that next time when you come across a different problem, but you might be able to apply a same set of logical thinking, and then you can come up with solutions for new problems and perhaps even develop new methods to deal with these new problems. So that is more important. And I believe that's the same for a lot of disciplines in a university. So the discipline of statistics is rather interdisciplinary in the sense that we draw our foundation from mathematics. So things like linear algebra, calculus, discrete math, they are quite important. And therefore, in the statistics curriculum, you still need to learn mathematics. So bad news for some of you who think that you can escape mathematics. In fact, mathematics is everywhere, even in economics and almost at every discipline. All right, so they are quite important because it trains us, the way of logical thinking. All right, and it's no surprise to all of us that nowadays, because the amount of data is just so vast and huge, there's no way you can do data analysis or things like this or study statistics without knowing how to code. So coding is very important. So when we say statistics depends on mathematics and computer science, we are referring more to the coding part. All right. So computer science is also a very well-established field. So there are things that deals with database and computer architecture, how internet is set up, and all this stuff. We are not going to delve too much into it. For the purpose of the statistics discipline, it's really more about coding, how we can code to write good programs to do data analysis. All right. So this is very briefly the curriculum structure for the statistics major. In the first year, you will take this course known as Introduction to Statistics and Statistical Computing. So very quickly, you'll be introduced to various important and fundamental concepts in statistics, and you will be also taught how to use a certain software to do computation. And this is also the course that can count as one of the CHS core curriculum. So this is the course that I was talking about a few slides earlier. Over here, all right? So the data literacy requirement. All right, so the data literacy requirement basically says that every student in NUS should have good skills in handling data. And it happens that the statistics introductory course, what we call the gateway course, fulfills this requirement. And in your second year, then you will learn more, in fact, from the second semester onwards, then you will learn more math in the area of linear algebra and calculus. This is the mathematical foundation that we talk about. And then we also take a few courses that, would set a good foundation for higher level statistics modules as well. And then we also do more in terms of statistical computing and programming. And in your third and fourth year, then we will cover more important statistical techniques like simulation, regression, and then the last list that you see over here, they are specific tools to teach students how to handle certain types of data. Like how do you handle data that is not numerical? So that's what the first course in categorical data analysis is about. And then how do you when you handle a huge amount of data, how do you do that? All right, now you can't just do it the same way as you handle a small data set. So that's what the second course in computer intensive statistical methods is about. And then there are also other areas that we cover so that you have a good and well-rounded statistical education. And then finally, in the third and fourth year, you also have some rather specialized but important statistical applications that you can take as well. So there are several different options over here. You have, areas in finance and business stats. You have statistical techniques that are very useful in data science. And then there are also, courses that teach you how you can handle, medical and public health data. For example, how do you do demographics, and then how do you handle the study of the spread of disease, which is what epidemiology is about, and how do you conduct a good survey? And also, when you involve in industries, how do you design and analyze experiments, and how do you do good statistical quality control? So these are very briefly, the courses that will be covered in this major. There are also some other aspects of the degree program, but I will just highlight a little bit. In the fourth year, students interested can actually do a final year project, and we will have a professor in the department supervise this particular project. This will be useful for students who plan to go for a higher degree. For example, you are interested to do a PhD in statistics, and then eventually you want to be a professor. Then this is quite useful, all right, to do a final year project, a research project. But for a lot of other students whose end game or end goal is to go to the industry, then you can actually go do an internship, and then it is quite useful because nowadays a lot of students find that it is very useful to go for an internship, and in fact, quite a number of students they end up being offered a job in the internship company that they intern in. So these are all very good options, and perhaps these are things that you can worry about a little bit more after you decide which discipline to apply to first. All right. So I think I had mentioned this. Basically, for the CHS degree program, you need to read a total of 160 units, which is 40 courses, and then for the stats major, you need to read 60 units, which is 15 courses, and then you can choose to do a specialization. So what you need to do is to read another 5 courses on top of the major requirement. All right. Now, for some of you who are thinking, this stats thing sounds good, but I'm not interested in stats that much. But maybe I want to do a second major in stats. That is also possible. So in fact, we have a second major program in statistics as well, and it's rather popular with a lot of engineering students. So they do basically 10 courses, and then you can get a second major in statistics. And for those who want to do a minor, it is also possible, and that is 20 units of 5 courses. So I think I've come to the tail end of what I want to say today, but these are some useful information that you can look at. You can check out these QR codes later. And I would just want to highlight one rather important point, which is that how do you apply to the statistics major? The fact is, you can't apply to the statistics major. As I mentioned, what you need to do is you need to apply to the College of Humanities and Sciences first. All right, and this is the link to apply, which you can find very easily on the internet. So you need to apply to the College of Humanity and Sciences first. All right. So once you gain entry, then before you start your first semester, you declare statistics to be your major. All right. So what is the cutoff guideline? If you scan this code on the previous slide, which is here, down here, right? The indicative grade profile. Maybe you can scan this first and then you can check out later. So this is what is known as the indicative grade profile. It is not a guarantee, but basically the indicative grade profile says that these are the grades of students who gain entry to NUS, to this particular college, in the previous round of application. All right. So this is what you will find on that particular document. So as I mentioned, you need to apply to the College of Humanities and Sciences. And for the last batch of offers that we gave out, the 10th percentile is ABBC, all right? And then we have an equivalent for Polytechnic and students from overseas as well. And then the 90th percentile is triple AA, all right? So this means that for last year, students at the lower 10%, they had an entry grade of ABBC. And then for those at the 90th percentile, it's all A's. And that's quite common for a lot of different faculties in NUS. So this will provide you with some indication of how things might be like this year. So I must say that this is just indicative, all right? It doesn't mean that this year this will be the same situation. It's really a matter of demand and supply, all right? So it could go up, it could go down at the 10 percentile. All right. Finally, if you have any questions, please feel free to ask a question later, or you can write to us over here. All right. And one last thing, this something for you to watch later. You can scan this QR code first. Basically, what happened was that one of our faculty member, he was interviewed on Talking Point quite a number of months ago, and this particular issue has got to do with the issue of blind box. So you can watch this video later, and it's quite a fun video to watch, and it also shows a real application of statistics in real life. All right, so that is all I have for us this afternoon. I will be glad to take in some questions if there are. All right, let me maybe stop my share and then I can attend to questions if there are any. Okay. Okay. My colleague just sent a link to the video, which was, I think, the video for the CHS student video. All right. So as I said, there's a whole range of different other videos over there. They are quite useful to let you find out a little bit more about the various different degree programs and the majors that we have in the faculty. All right. Okay. If there are any questions, I'll be happy to answer any over here. Just also as a preview of things to come. Immediately after this talk, if you stay on, my colleague, Professor Vic Gopal, at 2 p.m., he will talk about the data science and analytics major in the department. All right. So please feel free to stay behind for the next talk. Okay, last call. If there are any questions, anyone, I will be happy to answer. Okay, there is a common question. What is the difference between stats and data science? In fact, if you stay for the next talk, you'll discover that for stats and data science, the three basic ingredients are more or less the same, all right, which is stats, statistics, mathematics, and computer science, all right. So what I would say is that the statistics major, it's the focus and the ingredient, you will have more of the statistics part because of the fact that in a more traditional sense, a lot of statistics students, they work in industries that are less, for lack of better word, that is less reliant on the new and modern techniques of data science. So, for example, quite a number of the stats students, they work in places like, for example, the hospitals, government agencies, which, if you think about it, is a little bit different from the tech companies. All right. So, but in any case, you can stay back for the next talk, which will begin at 2 p.m. All right. Prof. Vic will tell you a little bit more. Oh, here he is now.
And you
Right.
can stay behind and we can talk more about the data science, then you can compare.
Yeah, right. But the three basic ingredients are the same. It's just a matter of which ingredient has more, which are heavier dosage of a particular ingredient. All right, and they are all good. In fact, a lot of our former students, they graduated with a stats degree. Quite a number of them are actually working in data science related areas as well. So, Profit will tell you that the reason why data science came about is because there's a more important need to train students who are more focused in working in certain types of industries, actually. Yeah. Okay. So I think there are no other questions. So perhaps what we can do is we can take a pause now, and then everyone can have a cup of tea and maybe go for a toilet break, and then we will resume at 2 p.m. And then Prof. Vic Gopal will tell us a little bit more about the data science and analytics program in the department. All right. So thanks for taking time. And again, let me encourage all of you, if possible, to come for the physical open house that is happening this coming Saturday from I think 10 o'clock to 5 p.m. All right. So I hope to see some of you there. All right. So have a good rest of the Sunday. All right. Let's take a break from now.